Hello scholars, welcome. Mr. Hinkle here. Today we are going to talk about water, this amazing, natural, renewable resource that is absolutely vital for all life on Earth. But not only that, it helps to shape and carve this beautiful world that we live in. So I'd like to do an introduction to water, discussing the water cycle, looking at why water is important today and in the past. We'll look at how we govern our precious water resource, and then tying all this up, we will introduce what is a river and then briefly describe fluvial processes. So let's get into it. All life on Earth requires water. And if we think of Earth as a system, there are four main spheres. The geosphere, that's the Earth. The atmosphere, that's the air. We have the biosphere, that is life. And the hydrosphere, which is water. Now you could also say part of the hydrosphere is the cryosphere, frozen water, because frozen water plays a very pivotal role on our Earth, but that's not our discussion today. Our discussion today is looking at the geology and the anthropology of water. Water shapes our planet. It's responsible for the processes of weathering, erosion, transportation, deposition, creating rocks that we see on our surface. It influences geological processes. We've got flux melting deep down in subduction zones, which creates magma differentiation, leading to volcanoes. It's amazing. And then it's also important for steam in volcanoes and hot springs and the like. So, the water cycle. The water cycle can be very complex, as we see here, as described by the United States Geological Survey, but I would like to make this a little bit more simplified. So we've got land and we've got ocean. Land and sea. Water in the ocean evaporates. That water in the clouds, in the atmosphere, condenses, and then it falls down to Earth as precipitation, making its way through various pathways, which we call runoff, back to the ocean. This is a very basic model of the water cycle: evaporation, condensation, precipitation, and runoff. We also have what plants do, transpiration in the middle, and lots of various pathways. It's not necessarily a linear path, but this is a very good basic understanding of the water cycle. So water moves from various reservoirs all over our Earth, and it is unequally distributed. So most of the water on Earth is located in the oceans. We're called the blue planet because oceans cover about 71%. The other 29% covering the surface of Earth is land. That means that most of the water on Earth is in the oceans, and that water is saline or salty. About 97.5 roughly in there of that remaining 3% of fresh water, which we go over here. Let me see. I don't need to stretch so much. Fresh water, about 2/3 is locked up in ice caps and glaciers. This would be the cryosphere I was mentioning. About 1/3 is located underneath the ground, groundwater. I've got another lecture on that. See that one? And then about 1% is surface water. 1% of the 3%, so we're talking a small fraction. Now, that water is mostly located in big lakes, in swamps, and in rivers. We think of the Nile River, the Amazon River, the Mississippi River as these humongous waterways. But in fact, they hold a very small portion of the overall total volume of water on our Earth, yet still play a pivotal, key role in our current and historical civilization. So, Roman aqueducts have been around for a very long time, moving water from one place to another because water has been important, as always, for consumption and agriculture. We need to drink water and we need to grow our food. So, humans can live where there is water, and we've gotten really good at taking the water from where it's readily available to where we need it. We see the importance in history through structures like aqueducts, through architecture like frogs, water lilies, and waterfowl. We also have stone monuments like the hook-nosed rain god Chalk, because water is so important for life. Civilizations have worshipped water as being one of the gods that bestows life upon this earth. Fast forward to today, water is highly regulated and of utmost importance for our modern civilizations. Let's go to the United States. About 355 billion gallons of surface water is used every single day. That's a lot of water. Think like a gallon jug of water, and then think if you had 355 billion of those jugs of water, that's how much water is used every day. Now, more water is used in areas with higher populations. California uses about 16% of national groundwater. Utah has a water shortage, but the Colorado River makes its way all the way down to the Gulf of Mexico and is shared by lots of different states. So we've devised very complex governance over our water resources. Here at home for me in the Central Valley, I'm in Fresno, California, there is a complex web of canals, kind of like the Roman aqueduct, but this is current, where we take water from where it's naturally located and transport it to the areas, the population centers that we need it. Specifically, big metropolitan areas, the San Francisco Bay Area, and the Los Angeles Basin. There is all kinds of study that we can do into the processes of water, the politics of water, the distribution of water. But for our introduction, it's important to know that water is necessary, it's vital for life, and modern civilization is built on how we distribute and regulate water from where it naturally occurs to where we want to consume it. So somehow we've got to have policies, water laws. Federal and state governments are working towards fair and equitable use of water so that not one organization can take all of the water and use it up, leaving others without water. I mean, this is the goal, right? As mentioned, the Colorado River has the Colorado River Compact. In 1922, this was made. So water rights and water law has been around for a very long time, trying to figure out who gets the water. Well, with all of this governance and all of this usage, there's also impacts to our water supplies. Thus, we need water protection. 1970, the EPA, the Environmental Protection Agency, created by President Nixon, was developed to ensure that our environment is not negatively affected in the worst possible ways. So this is a great organization. Shortly thereafter, the Clean Water Act, 1972, the Safe Drinking Water Act, 1974, these two laws basically say water is a human right, and every human deserves access to clean drinking water. And if that's the case, then we need to make sure we are not polluting our freshwater supplies too badly that we cannot uphold this human right for every person in our country. In fact, I believe human access to clean drinking water is a global human right, and every person in the world deserves and is entitled to fair and equitable access to clean drinking water. So, water is extremely political. But this is not a water politics lecture. It's important to know that that exists. What I'm really interested in talking about, and the subject of this series of lectures, is surface water, and more specifically, rivers. Rivers transport water over the surface of the earth. River is interchangeable with the word stream. Stream is the geologic word for it, and it is surface water confined to a channel between definable banks, important for erosion, the movement and the transportation of sediments, small broken pieces of rocks, and it helps to shape the surface of our earth, creating the surface topography that we see today. Let's see, I mentioned these two already. Rivers transport water and sediment from the mountains to the oceans. And streams not only are important agents of geologic change, but to review, they also provide drinking water for human consumption, irrigation for our crops. They generate power. Hydroelectric is a huge source of energy. They create recreational activities such as swimming, fishing, and boating. And rivers are important habitat for wildlife, creating a slew of various ecosystem services, including water purification. That is great because we want to drink clean water. So the science of rivers is called fluvial geomorphology. Fluvial means flowing water, geo, earth, morph, the way that it looks, ology, the study of. So river science, or fluvial geomorphology, is studying the way the surface of the earth looks as shaped by water. And important topics within this that we'll discuss in this series are fluvial processes, channel morphology, and sediment transport. This dictates why rivers look the way that they do and how they function. These are the processes of rivers that shape our landscape. So, to conclude our introduction to surface water, water is essential for humans that live on Earth. We need it. There is no life without it. A large portion of our surface water is available for human use in rivers, even though it's a very small portion of the overall volume and distribution of Earth's water. Rivers have a suite of unique characteristics that determine the form and processes they exhibit, in which I'm very excited to share with you in the coming lectures. So this is our introduction to surface water and our intro to rivers. Thank you so much. I'll see you again.